After discussing the benefits and negative aspects of the OSI model, now let's go into the depth of each and every layer, starting from the physical layer. We have seen the physical layer is the layer which is the lowermost layer in the OSI model. Now what this layer is doing, or what is its functionality in the OSI model. So this particular layer converts the logical ones and zeros coming from layer 2 into electrical signals. As we have seen that every layer has to offer services to the layer which is just below it, and it has to work with the layer which is just above it, and at the boundary there exists interface which defines the primitives and the services and the other things to work in this particular manner, the responses and the indications and so on. So this particular layer is the layer which converts the logical ones and zeros coming from the data link layer into electrical signals. And it is also responsible for transmission of the electrical signals over a communication channel. So that channel could be anything right from the optical fibers or UTP cable or coaxial cable. It could be even wireless also. So that is the main function of the physical layer. So here, what are the main topics or main things which are important? So physical layer decides, or you need to specify that what are the transmission media in the physical layer, basically to which transmission media it's going to deal with. It could be, as I said, it could be a fiber optics in case you require very huge bandwidth, or it could be a Cat6, Cat7 kind of media in case it is LAN, and so on. Another thing which is decisive in case of physical layer is what kind of encoding, because encoding comes at this particular juncture. So therefore, what kind of encoding is going to be there will be decided at the physical layer. Another thing is modulation. What kind of modulation? All of you are aware of modulation. It's changing the signal, okay, and the modulation, the kind of modulation. In case of even the industrial environment, you can have FSK. So what kind of modulation is decided at the physical layer? And of course, the older standards like RS-232 or much latest standards like RS-422, these are again decided at the physical layer. Now, what is that device, networking device, which we are going to study in detail, exists at the physical layer? Either it's a repeater or hubs. Repeater is a device which is used in case long distances are involved, because as the distance increases, the attenuation of the signal increases, and therefore repeater is a device which will ensure the regeneration of the bits. It's not exactly amplifier, it's a regenerator. So that logic 0 will be regenerated as a logic 0, logic 1 will be regenerated as logic 1. And in this way, it will again ensure that the signals, the bits will gain their original levels. So that is the function of the repeaters. And typically they are used whenever long distances are involved. And then hubs and switch. Basically hubs, a multi-port repeater, could be a device which is used at the physical layer. So these are the details of the physical layer. Moving to data link layer, what are the issues? So data link layer is basically deals with the error control. So why error control? Because this is just to compensate for the imperfections of the physical layer. Because the physical layer might introduce certain imperfections, and those imperfections are taken care at the data link layer. Another issue or another process which is handled at the data link layer is the flow control, so that the swamping or the incompatibility of the speed between a fast sender and slow receiver and vice versa can be taken care, and this is done at the data link layer. So here the main issues are, what are the framing methods? What is the error detection and correction methods? What is the So we have seen that CRC is used mostly in the error detection and correction. So the error detection and correction methods, they are decided at the data link layer. And apart from that, the flow control, the frame format, these are the things which are decided. And IEEE and LAN standards, IEEE LAN standards. So as I have already mentioned that IEEE is the apex body for the entire networking fraternity. So the standardization part is decided or is adjusted at this particular level by the apex bodies. And the devices at the data link layer are bridges and switches. So bridge is a device, we'll see the details, what is a bridge and what is its functionality, but this particular layer appears at the data link layer. And switches, so switch is having some sort of intelligence and it can route the data through subnets so that there will be less congestion. And the functionality of the switch is decided or it is assigned to the data link layer. Of course, we are going to see the details of this. The third layer is the networking layer, network layer. What are the functions at the network layer? It basically controls the operation of the subnet. We have already seen the concept of subnet, which connects the hosts, and the operation of the subnet is assigned to the network layer. And this involves routing the packets from source to destination. So there is a source of data and there could be a destination of data which is far apart from the source. And there exist many paths, alternate paths. So routing of the packets, the small chunks of data, keeping in view the time, keeping in view the noise on the channel, keeping in view the congestion, the routing is done, and there are many algorithms for this. But this routing is basically done at the network layer. Another function at the network layer is the logical addressing. We have seen the logical addressing and physical addressing. So the logical addressing part is taken care of at the network layer. So the topics which are important at the network layer, or the concepts or the issues which are important at the network layer, those are how the internetworking is being done in a complex network. What are the routing algorithms? As I mentioned, that based on the ease of data transmission, based on the throughput, based on the delay involved. So all these things are basically taken care in the routing algorithms. And then as I mentioned, that logical addressing, so it comes under IP protocol, because every machine on the network has got certain address, and this IP address is again a part of the network layer functioning. So the device which is coming at the network layer, those are routers. So you must have heard a term called as layer 3 switch or layer 3 router. That means it will encompass the functionality of layer 1, layer 2 and layer 3. So these kind of things are common in the networking. The next layer is the transport layer, and this particular layer, it provides additional quality of service. The QoS or quality of service is very important. You must have seen that nowadays even the video calls are done on the in the networking environment, and there is a tendency to drop the calls. So it all happens because of poor quality of service. So quality of service is very important even in case of video streaming and other applications. And transport layer is the layer which takes care of the quality of service. And this particular layer is so important that it is regarded as the heart of the OSI model. So you can imagine that the entire functioning of the OSI model depends on the functioning of the transport layer. So here the main issues which are important, these are whether it's going to be a connection oriented network or connectionless services. Both the services are there. So we'll be discussing more on this in the next chapter. And then what kind of protocols are used, whether it is a transmission control protocol, which is TCP, which is very popular, or it could be user datagram protocol. So again, the details will be discussed when we discuss about more about the devices. But these are the issues which are important at the transport layer. The quality of service is basically a decisive factor for a well-designed network, and it is handled at the transport layer, and therefore this is the heart of the OSI model. The session layer, again we have seen, it's very important because when two machines, two nodes or two hosts, they communicate over the network, then they engage a session, and this session allows them to have synchronization. So session layer, it allows the users on different machines to establish sessions between them. So it is a part of dialog control. So dialog between two nodes or two hosts, and therefore this dialog control is very important. And this dialog control often involves the token management, because token is just like a basket, and this basket is passed between, it keeps on moving in the network, and it has got the addresses from of the source machine, addresses of the destination machine, and the data which is to be transferred. And whenever there is a match with the address of the receiver machine, then the data is transferred. So this token management is very important. So in a way, this particular layer is all about how the synchronization between the source and destination and the data transmission part is handled at the layer, at this particular layer. The presentation layer, basically it concerns with the syntax and semantics of the information. So we have seen that just prior to application layer is where we operate the network, like the browser or the user interface. So the data to the application layer is given by the presentation layer. So it basically deals with the syntax and semantics of the information. It preserves the meaning of the information, right? And therefore the data compression and encryption, these are the two functions handled at this particular layer. So compression allows you to have transmission of huge amount of data in a less time, because on a network the time is very important since there are so many clients. And data encryption allows you to have security. So security and throughput, these two functions, they are handled at the presentation layer. And as I mentioned, the presentation layer gives data or gives functions to the application layers, where there are protocols, and this protocol depends on what kind of service the host or node is required. So this could be transfer of files, which comes under file transfer protocol. This could be a very popular web oriented service such as hypertext transfer protocol, HTTP, or nowadays even HTTPS, secure hypertext transfer protocol, which is more popular. It could be SMTP, simple mail transfer protocol, just for email programs. It could be a simple network management protocol called as SNMP. For the file system, it could be a network file system protocol. Or if you want to log in to a remote server, which is having some kind of functioning or software like MATLAB, then you can use the telnet. So these are the protocols which are basically used in the application layers. And just these are all the details of the basic functioning and the issues which are handled at every layer of the OSI.